All right, let's talk about a classic problem in software development, one that can get super costly if you get it wrong. What happens when two people try to grab the exact same thing at the exact same time? We're going to dive into this thing called a race condition and then show you a really elegant solution for it called optimistic locking. So picture this, right? You've got this super popular online store, and there's only one amazing discount voucher left. We have two users, user A and user B, and they're both ready to pounce. Their fingers are on that claim button, and they both click at pretty much the exact same time. So who gets it? Well, the answer isn't as simple as you'd think. It gets messy. So just before that big click, this is what our database looks like. 10 vouchers were available in total, 9 are already gone, which leaves just 1. The stage is perfectly set for a showdown. Okay, so what's the big deal? What actually goes wrong? This is where we hit the real heart of the problem, a tricky little thing developers call a race condition. Let's walk through this step by step. Because user A and user B click almost simultaneously, their requests kick off two separate transactions. First, both of them read the data from the database. And what do they see? They both see claimed vouchers is 9. Okay, makes sense. Then they both do their little check. Hey, is 9 less than 10? Yep, for both of them. So here's the kicker. Both transactions think the claim is totally valid. They each get ready to update the count to 10 in their own little memory space. Then they both commit that change to the database. And the result? The database says 10 vouchers have been claimed. But oops, we just gave away 2 vouchers instead of 1. So you're probably asking, wait, why didn't user B see the change that user A made? And that's a great question. It's because of something called a persistence context. The easiest way to think about it is like they're both working on a Google Doc, but offline. They each download their own copy, they both make their edits, thinking they're the only one, but those changes don't get synced back to the main document until the very, very end of the process. By the time they hit save, it's way too late. They've both made their decisions based on old, outdated information. And that right there is a textbook race condition. You've got multiple things reading the same data, doing some math, and then writing it back, all without talking to each other. The result? Almost always, it's corrupted data, a real mess. So what's the bottom line? The system broke. Plain and simple. We gave away 2 vouchers when we only had 1 left. Our data is now wrong, and that's not just a technical problem, that's a real business problem. Okay, so how do we fix this mess? Well, thankfully, there's a really elegant and powerful strategy called optimistic locking, and the name is a huge clue. It's optimistic because it basically assumes that these kinds of conflicts are going to be rare. So instead of locking down the data from the start and being all pessimistic, it just lets everybody do their thing, and then right at the very last second, it does a quick check to see if anything went wrong. Now, you might be thinking, this is going to require some super complex fix, right? Nope. The core idea is unbelievably simple. All we have to do is add a version number. That's literally it. Let's see how this one tiny change completely solves the problem. So here's what that looks like in our database. Before, we had our regular columns. Now, after, you can see we've just added one new thing, a version column. The rule is simple. Every single time we update this record, we're going to bump that version number up by 1. Okay, rematch. Let's run that race again, but this time with our shiny new version column. So both requests come in. Let's say user A is just a hair faster. It reads the data, and it sees version equals 0. So it sends its update to the database. But this time the instruction is different. It says, hey database, update this row and set the version to 1. But, and this is the important part, only if the version you have right now is still 0. The database looks, sees version is 0, so success. The update goes through, and the version is now 1. Then, a split second later, user B's request shows up. It tries to do the exact same thing. It says, hey, update this row, but only if the version is 0. Well, guess what? It's too late. The version is already 1. The database sees that mismatch, the update affects 0 rows, and boom, the system throws an exception and safely rolls back user B's entire transaction. Problem solved. No extra voucher gets handed out. And honestly, it all boils down to this one simple addition to the where clause. This is the whole magic trick behind optimistic locking. That little and version equals question mark is basically telling the database, look, I only want you to update this if it's the exact same version I read a moment ago. If someone else has touched it and the version is different, just stop, don't do it. All right, so we've got a solid solution. But can we make it even better? Of course we can. Let's look at a pro tip to make this even more efficient. You see, when we're saving our changes, we usually have a couple of options. The standard save command is kind of lazy. It waits until the absolute end of the whole transaction before it actually writes anything to the database. Now, if a conflict happens, that means you might have done a whole bunch of other work just for it to fail at the last second. All that work was wasted. But if you use save and flush, it's totally different. It writes the change and checks for that version conflict immediately. This is what we call a fail-fast approach. It's way more efficient because it saves the server from wasting precious time and resources on a transaction that was just doomed to fail anyway.
Okay, let's pull back for a second and talk about what this really means for you, whether you're a developer or just curious about how we build software that doesn't fall apart. So, what are the big things to remember here? First, anytime you have multiple things happening at once, you got to be worried about race conditions. It's a minefield for your data. Second, optimistic locking is your best friend here. It's like a shield that prevents data corruption by just checking a simple version number. And the best part? It's usually super easy to implement. Sometimes it's just one line of code, like an @version annotation. And finally, remember to use save and flush when you can. It helps you find those conflicts early, fail fast, and save a ton of server resources. It's just a fantastic example of how one tiny smart change can save you from massive headaches down the road.
So we did it. We protected the database, user B's request got blocked, no extra voucher was given out, the back end is totally safe. But that leaves us with one last really important question. What about user B? What did they see? Did they just get a big, ugly error message? Did the page just freeze? This is where the job of a developer goes beyond just the back-end logic. Now we have to think about user experience, about maybe trying the request again automatically, and how we turn what was a technical failure into a smooth, graceful experience for the user. But that's a whole other can of worms and a topic for another day. Thanks for joining this explainer.